A long time ago in a galaxy far, far away, there was a dark force preventing the young Jedi fighters from passing their final exam. But the Republic has called for a secret MAT1033 final exam review study session to help the Jedis regain their strength to fight evil. To make sure all Jedis are present and attentive, I would like you to raise your lightsabers by clicking on the hand. Okay, everybody raised their lightsaber. Good job. Should you have a question during the session or feel overwhelmed by the attacks of the droids, you can type into the cruiser's text box and either Obi-Wan Kenobi or Luke Skywalker will hurry to the rescue. I am Yoda and I will host today's study session to train you and awaken your skills and strengths needed to forge your own future. We will battle about 30 droids, which should take no longer than 2.5 light years. May the Force be with you. So let's go to fight the first droid. Okay, this droid is about long division, where we have to divide this polynomial. So what we should do first, let me just make sure that my pointer is working in pen version and a nicer color right there. So first we should rewrite this problem by writing the p plus 9 outside and then writing the p squared plus 5p minus 29 inside. We have to make sure that we got these variables in descending order. So if the problem starts with a p squared, then the next one should be p and then no p. So we don't have to fill in nothing. These are in descending orders. Nothing is missing. Now we can start dividing by using long division. So I'm going to ask myself, how many times or by what do I have to multiply this first p to get p squared? To get p squared, I have to multiply by another p, because p times p is p squared, and then I also have to multiply this p by the 9. So p times 9 is plus 9p. Okay, once I did this, I have to subtract, and that changes the signs inside. So now the p squared would be negative, and the 9p would also be negative. And then I can subtract down or add down, and that should always cancel out the first term. P squared minus p squared is gone, just 0. And then 5p minus 9p gives me negative 4p. I'm bringing down the next term, which would be negative 29. And now I have to start all over again. By what do I have to multiply this first p to get negative 4p? Well, it already has a p, so I have to multiply it by a negative 4. Now I can check. Negative 4 times p gives me negative 4p. So that's exactly what I wanted, but I also have to multiply this by the 9. And negative 4 times 9 is negative 36. Thank you, Obi-Wan Kenobi. Okay, now again, remember you have to subtract, which changes the signs. So both of these become now positive. Adding down, first term cancels, and negative 29 plus 36, you always subtract the smaller from the bigger number and then keep the sign of the larger, so it should be a positive. 7. Okay, there's nothing else that I could break down, so actually I am done, but in this particular problem I have a remainder. So now I just have to figure out how to actually write the answer. So this would be the quotient, which is p minus 4, and then the remainder, it's positive, so it's plus 7, but the 7 should have been divided by the p plus 9. So I still need this in the fraction, in fraction form. And if you look at your review packet, if you had a chance to print it out, this one is answer choice D. Okay, I'm going to check if my young Jedis have any questions. If not, we are moving on to fight our second droid. Okay. This droid wants us to find an equation of the line through the pair of points and then write the equation in standard form. And I wrote the standard form of an equation right here, ax plus by equals c. So when we are given 2 points and we are asked to write an equation, we can use the slope formula, which starts with m, and then y2 minus y1 over x2 minus x1. So I have a lot of subscripts here to make it easier for myself. I should also label my points. I'm going to call this my first point, so this should be x1 and y1. And I'm going to call this my second point, so I'm labeling it x2, y2. It's very important to start off labeling correctly, otherwise it might going to be hard to get the correct answer. So now I have to plug in the values starting with y2, which is 9, minus from the formula, and then my y1 is 6, all over x2, which is negative 4, minus from the formula, and my x1 value is negative 8. Simplifying the numerator first, 9 minus 6 is 3, and negative 4 minus minus, this turns actually into a plus. A negative times a negative is a plus. So now negative 4 plus 8 leaves me with a positive 4. So my slope of this equation, or of this line that is going through the 2 points, is 3 over 4. I have two options of using 2 different ways to get to the same solution. So I could either use the slope intercept form, which is y equals mx plus b, and plug in my m, plug in one of the points, the y value and the x value, find my b, and then rewrite it. Or, and this is what I'm going to do in this case, I'm using the point slope formula, which is y minus y1 equals m x minus x1. So both of these work, you should get the same answer, but I'm going to choose to use the second one. And I'm plugging in my values, and for the point, which indicates the x1 and y1, I can choose either one of these. It should still give me the same answer. Usually I choose the easier one, but both of these look the same, so it doesn't really matter. I'm going to pick the first one. Y minus my y1 value is 6 equals, I found my m right here, 3 over 4. And then x minus my x1 value was negative 8. Okay, now simplifying, y minus 6, so I'm distributing this here, and I also can combine my 2 signs. The negative times the negative should be a positive 8. So 3/4 times x is just 3/4x, and then 3/4 times a positive 8, I'm going to do it here on the side, times 8, or I can make it a fraction as well. Gives me, I can cross simplify before I straight multiply. The 4 goes into 4 one time. The 4 goes into 8 two times. They share a common factor of 4. And then straight multiplying. So I'm getting 3 times 2, which is 6 over 1, or just 6. So right here plus 6. Okay, so now remember we need this in this form, so we should have the x values and the y values on one side, and then the constants or the numbers on the other side. Okay, so because I want this term to be positive, the x term, I want this term to be positive, usually it's positive, I'm gonna move the 6 over here and the y to this side. So starting with subtracting y from both sides. Now I'm running out of space. Let me erase my side work real quick. Okay, I am getting this cancels out on this side, so I'm left with -6, and then I had 3/4 x on this side already, and minus my y plus the 6. So moving the 6 over, subtracting 6 from both sides, this gives me -12, 3/4x, and minus y. Okay, most likely you're not going to find your answer as it is, because also when you are asked for writing an equation in the standard form, they do not allow you to have any fractions. So we're going to use the method of eliminating the fraction by multiplying by the least common denominator. In this case, we only have one fraction, so it should be easy to identify the least common denominator. I'm going to give a chance for my young Jedis to answer. So if you know what is the least common denominator of this fraction, please type it into your Cruiser text box. And Obi Vanina Kanobi will give me a sign and let me know what you guys think. So we need to find the least common denominator to eliminate those fractions. I'm going to change my color. Meanwhile, you guys are thinking. So what is it? Okay, because I don't really hear no responding from nobody. I am wondering if you actually can hear me. Can you guys at least raise your hand if you can hear me? Yes, okay, I got some hand. All right, so, okay, somebody finally answered. Yay. So the least common denominator is 4. We're going to multiply the entire problem by 4 to eliminate the fraction. So 4 times -12, and then also 4 times the 3/4x, and again 4 times the y. So this should leave me, what? I just wanted to change my color back to blue. So 4 times -12 is Obi Vanina Kanobi, -48, and then 3 times 3/4. As you can see, I can make it a fraction, and then I can cross cancel. Both of them have a common factor of 4, so 4 goes into 4 one time, 4 goes into 4 one time, and then I'm left with 1 times 3x, which is 3x, and my last term is minus 4y. So if you look at your packet right now, well, it's still not really nice. You can rewrite it by writing the 3x minus 4y on one side and then the negative 48 on the other side, but it's the same. You just need to be able to manipulate your problem to fit the answer choices, but still being equivalent. Like, don't make out of a negative a positive sign. It still needs to have equal value. And this is answer choice A. Okay. Thanks, my young Jedis, for helping out. Let's move on to fight the next droid. This droid wants us to write an equation of a line, and we are given the following properties. This time they want us to write the equation in slope-intercept form. So right here is the slope-intercept form given. And the properties are that this new line needs to go through the point negative 4, 2, and it has to be perpendicular to this line. So whenever I'm asked for perpendicular or parallel, the first one I'm going to determine is the slope of the line that I'm looking for. So the slope of the line given, if it's in this form, it should be the m, and the m is in front of the x when the equation is solved for y, and in this case the slope is 4. Now they want me to find a perpendicular slope, so I'm going to give my Jedis a chance to answer here. Can you tell me what is the perpendicular slope of m equals 4? Type it into the Cruiser text box. Okay, I have some answers. Okay. Young Jedi, you are almost there. Somebody said -4, and then somebody else said 1/4. Well, if you guys work together, you got it. Actually, the perpendicular slope would be the opposite, which makes the +4 a negative, and then the reciprocal, which makes the 4 a 1/4. So you see how important teamwork is? So you guys all know a little bit. If you work together, you have it in one piece. But unfortunately, on the final, you're going to have to work independently. So remember, the perpendicular slope is the opposite, which makes it a negative when it's a positive, or a positive if the original slope was a negative, and then the reciprocal, just switch those numbers. If you have 4, you can make it a fraction and then just flip them upside down. So that's what is meant by reciprocal. So we found our perpendicular slope and we are given a point, so we can use again from the previous problem the point slope formula, which was y minus y1 equals mx minus x1, which is the more professional way of solving it. But like I said, you can always use the y equals mx plus b as well. So let's plug in our information. We have the y value where this is the x and this is the y. So we're plugging in, this is not meant to be an equal sign. So we're going to plug in the 2. The negative sign comes from the formula, and then our slope, we determined our perpendicular slope to be -1/4. X, and our x1 value is a -4. You have to be really careful with your signs so you're not messing up. So solving for y, we can combine these two signs. A negative times a negative is a positive. And then we distribute the -1/4 to everything inside the parentheses. So -1/4 times x is -1/4x, and -1/4 times a +4, because those two signs combine to a plus. Let me do it on the side so you guys can see what I'm talking about. times a positive 4 now, and we can make it a fraction. As you can see, I can cross cancel. Both of them have a common factor of 4, so 4 goes into 4 one time, 4 goes into 4 one time, and I'm left with a negative 1, so minus 1. Y needs to be all alone. Let's move the 2 over by adding 2 to both sides. That eliminates the 2 on this side, so I'm left with y equals negative 1 4x, and negative 1 plus 2 gives me a positive 1. Okay, so this is the line perpendicular to the original line going through the point given. And if you look in your packet, question number 3, this is answer choice C. Obi-Wan Kenobi, we good? Okay, no questions. Let's move on. Question number 4, which we have to solve a system of linear equations, and we need to use the substitution method. So in this case, we are told to use the substitution method, but usually you can use any method to solve a linear system of equation. You should always get the same answer, but depending on the equations given, one method is easier to use than the other. And because in this case, the first equation is already solved for one variable, it is better to use the substitution method. So all we have to do is plug all this in for x into the second equation. So I'm starting with negative 7, and now instead of x, I am going to write negative 17 plus 3y, and then I continue with my equation. Negative 4y equals negative 6. So as you can tell, there's only one variable here now, which is a y, so I'll be able to solve it. Using distributive property, negative 7 times negative 17. If you think Yoda knows that, no, Yoda doesn't know that. So my young Jedis, please either calculate it or use your calculator and tell me what's negative 7 times negative 17. Okay, good job. May the force be with you. I got a 119. Very nice. And then negative 7 times a positive 3y. Okay, I'm pretty sure I can do this. This is negative 21. Please interrupt me if I should go wrong with any calculations. It's early in the morning. And continuing with my problem, bringing down the negative 4y equals negative 6. Next step would be to combine like terms on one side right here. So negative 21 minus 4 gives me a negative 25y. All that equal to negative 6. Okay, solving for y. So subtracting 119 from both sides. That's gone. I got a negative 25y on this side. Negative 6 minus 119. Both of these are negative, so I'm actually adding but keeping the sign. And that gives me 125. Okay, last step, dividing by a negative 25. Negative 25. So y is left. And then this one, I can also do my head because I like money, and I'm just saying $1.25. How many quarters fit in $1.25? There are 5. And a negative over a negative gives me a positive. So y equals just 5. But in your case, you're welcome to use the calculator if you're not sure about if you have the correct answer. Okay, we found our y value of this point where the two equations are crossing. Now we have to find our x value. We going back and choosing either one of the original equations to plug in our y value. Usually I choose the one that looks easier to me, so in this case the first one, but you can choose either one of them, you should still get the same answer. So x equals -17 plus 3, and now for y I got 5. So simplifying everything, this is a 7, oops, and a +3 times 5 is 15. Now -17 plus 15, I know my answer going to be negative, and 2, -2. So I found my x value. Usually you are required to write it as a point because this represents the point where the two equations are crossing. So the x value goes first and then the y. So now you're ready to check if this is actually a valid answer. Yes, I see it in the packet. This is answer choice B. Okay, if there are no questions, then we move on to find droid number 5. What? Yeah, okay. Obi-Wan Canova is talking to me here. Okay, I see somebody else logged on, so welcome to our study session. Again, I'm Yoda. So let's solve this system of linear equations, but this time instead of using the substitution method, we're going to use the elimination method. And elimination you use usually when the variables are nicely lined up, and then you basically just adding down. But we cannot add down yet because nothing would cancel out. We first have to manipulate these equations so one of the variables would cancel out, and it doesn't matter which one. So in this case, I'm going to choose to make the x variable cancel out. So I have to multiply 3x by, let me see. So we need to find basically a common multiple of both of these numbers. And I believe 24 would be a good option. So to get to 24, we can multiply the 3x by a -8, and -8 because one of them needs to be negative and the other one positive. And this equation we multiply by a +3. So now on top I will get a -24x, and the bottom I will get a +24x, so that works. But I have to multiply each term by that number to keep it equivalent. So let's start. Looks like a lot of work here. -8 times the 3x gives me -24x. Then -8 times 6y gives me -48y. And -8 times -1 gives me a +8. Again with the bottom equation, but this time we multiply by 3. 3 times 8x gives me a +24x. 3 times 7y is a +21y. And 3 times a -8 is -24. Now we're ready to add down. So -24x plus 24x is gone, and -48 plus 21, -27. Thank you, Obi-Wan Kenobi. And then 8 minus 24 is definitely a negative, and it should be 16. 16 with a question mark, which means young Jedis, please stop. Stop me if that is not correct. And now we have to get y by itself. So let's divide by a negative 27. And I'm questioning myself because I realize that this final answer is going to look a little bit weird. But do not doubt yourself sometimes. Some answers look weird. That does not necessarily mean they are incorrect. The only thing I have to do here is simplify. So negative over negative gives me a positive. I have to see if 16 over 27 could be reduced, but I don't see any. Do they have common factors? This one has 4, 8, and 2, and this one has 3, 3 and 9. So no, they don't share any common factors. This should be your answer. 16 over 27. Even if it looks weird, there should be a y value. So now we're going back to plug it in either one of the equations. I'm probably going to pick the first one just because they are smaller numbers. And we're plugging in this y value into the first equation. So we have 3x plus 6, and then for y, we plug in 16 over 27. Then continue on with the equation equals negative 1. Okay, so because this is only one fraction, and I'm pretty sure that my x value is going to be a fraction as well, I am not going to cancel out the fractions in this case. I'm just going to stick with it and work my problem to find the x value. So 3x, and then I can make this a fraction as well. I can check if I can cross simplify. So the 6 and the 27 share a common factor of 3. 3 goes into 6 2 times, and 3 goes into 27 9 times. So I'm straight multiplying what's left over. 2 times 16 is 32. And 1 times 9 is just 9. And all that is equal to negative 1. Okay, solving for x, so now I have to add this subtract this fraction to both sides to eliminate it from the left side. And subtracting 32 over 9. On this side, it cancels out, so I'm left with 3x. And now I got negative 1 minus 32 over 9. When I subtract or add fractions, I need the same common denominator. In this case, 9 is my least common denominator. This one is already 9, so I should multiply this side by 9. And I got negative 9 over 9 minus 32 over 9, which gives me a 3x. It should be a negative answer, and 32 plus 9, I have to add these are the same signs, 41 over 9. Okay, my last step is dividing by 3 on both sides, and I'm going to write it like this because otherwise it would be too many fractions. I'm going to go over here because I'm running out of space. I'm writing a little bit too big. So on this case, 3 over 3 is just 1, or x. And on the other side, when I'm dividing fractions, I can make this a fraction as well. I can use the rule of keep, change the sign, and flip. So I keep my first fraction, I changed the sign to multiplication, and then I flipped the second fraction, so now it becomes 1/3. I can ask myself if I can cross simplify something. No, 41 and 3 don't share a common factor. 9 and 1 don't have a common factor. So I'm just going to straight multiply. Negative 41 times 1 is negative 41. And 9 times 3 is 27. I found my x value. Even though it's a fraction, you could have a fractional answer. And remember, this is the point where those two equations crossing, so I should write it in a point form. First my x value, and then my y value, which I lost in all this. All right, here's my y value, so 16/27. That should be my final answer. And if I am correct, then this is answer choice C. Yes, I am correct. I'm just joking. All right. Are there any questions, Obi Vanina Kenobi, before we turn over? Okay, there actually was a question. Obi Vanina Kenobi didn't pay any attention. But I guess we did answer it. It was about the negative 16 over negative 27. Yes, it did turn into a positive. So, okay, good. Before we switch, I have something wise to say, like Yoda always has something wise to say. So no, try not, do or do not. There is no try. I hope you guys get it. Just do it. So here is Obi-Wan Kenobi.
Okay, good morning all. I'm gonna be your Jedi? No, you're the Jedi. I'm a Jedi too? I thought they were Jedis. Okay, anyways. Ah, you guys are Jedis wannabe. I'm so sorry. Okay. Okay, until you pass the final exam, you are gonna be a Jedi wannabe. So I am the Jedi Master. So we're gonna start on question 6, which is a word problem. And it says solve the application by using systems of linear equations. So there were 510 people at a play. The admission price was $2 for adults and $1 for children. The admission receipts were 830. How many adults and how many children attended? Okay, I'm gonna use, instead of X and Y, I'm gonna use A and C. A for adult and C for children. Oops. Okay, so I had some adults plus some children, and altogether I had 510 people. Okay? Okay, I have a question. Why am I using A and C without X and Y? It makes more sense to me because then at the end, I don't need to go double check what was the X, what did I label the X to be? Did I label the X to be adults or did I label the X to be children? So if I use A and C, I now know that A is adults and C is children. Thank you for asking that. And okay, I also know that there were $2 for adults, so $2 for adults, and then $1 for children. And I know that that total to $830. So I get the people with the people and the money with the money. Okay, so we can use this to solve by, what do you guys want to solve it by? Substitution or addition method? I'm going to give you a few seconds to answer. Then tech your answer on the cruiser text box. Okay, I get no answer, so I'm gonna pick myself. I'm gonna solve. Okay, somebody wants me to wait. 2, 1. All right, that was too many light years. I'm just gonna pick. So I'm gonna solve with elimination, which means I'm gonna times this one by -2 because I'm trying to eliminate the adults, not really like eliminating people, just the A. So I'll have, when I distribute this -2 throughout the whole equation, I'll have -2a minus 2c equals to, okay, I don't get help here. I'm guessing negative 1020. Is that correct? 2 times 510. Oh, thank you. Okay, the a's cancel out. Now I have 1c minus 2c. That's going to be negative. I could put 1c, but it's totally unnecessary, so I'm just going to say negative c equals to, the answer is going to be negative. Okay, I'm waiting for Yoda to help me out here. 1020 minus 130 minus 830. Okay. All right, that would be 190, but I don't want negative c, I just want c, so I'm going to go ahead and divide by -1 on both sides, so c equals 2 becomes positive 190. Okay, so that was children. See, now we don't need to worry. We know that there were 590 children at the, where was it, at the play. Now I can just go back to my original. I'm going to pick this one because that's where all the variables have no numbers in front of them. So I'll do less work. So I go back. I'm going to substitute C, the children's, for 190. So I'll have A plus 190 equals to 510. Solving for adults, I'm going to subtract 190 from both sides, and I would appreciate if somebody told me, and by somebody I mean my Jedi Master Yoda, 510 minus 190. Oh, oh, you want me to do it like in my head? Okay. Okay. All right, so 320 adults. Oh, thank you, Jedi's wannabe. 320. So I, well, normally we put this as a point. I'm gonna do it just for the, no, I'm not gonna do it because they're actually asking me how many adults, how many children. So I'm just gonna say 190 children, if I can spell children. Okay, and 320 adults. Because at this point, I know that I didn't label, so one of them could be my X, the other one could be my Y. Okay, let's go to question number 7, which is a factoring problem. Awesome. All right, can somebody tell me what should I use to solve this? Which of the factoring methods? Is it the difference of squares? Do I hear a yes? Nope. Okay. Is the difference of cubes. Okay, it can't be difference because I have a plus sign right over here. So it's going to be the sum of cubes because I have one perfect cube here, another perfect cube here, and separated by a plus sign, which the formula is going to be A plus B times A squared minus AB plus B squared. Okay, first thing I need to do is to cube root my first term. So can somebody tell me what's the cube root of 125s cubed? Because that's going to be my a. Jedi wannabes? You guys don't like this name? What? Padawan? Is anybody here a Star Wars fan? Because I'm definitely not, and I don't know what what is it. What do you guys are called? Okay, so what is it? Somebody say 125s. The S part is right, but however, you have to cube root the 125 as well. And if you're not sure how to do it, for me, the fastest way to do it is doing the factoring 3. So I get 5 times 25, and 25 is 5 times 5. Since the index is a 3, we are looking for groups of number that are the same, but groups of 3. So I have 1 right here. So my answer would be 5s. So that's my B. Actually, I think I'm going to use a lowercase s just so it doesn't get doesn't look like it doesn't look like a 5. Then okay, so then it's a lowercase s in cursive. Okay, B, my B, I have to cube root it 2. The cube root of 1, I messed it up, is going to be just 1. So now I have my A and my B. I can just go ahead and just substitute straight up in the formula. So A is 5s plus B, which is 1. A squared would be 5s squared, which is 25s squared, minus AB, which is basically A times B. So it'll be negative 5s, because 5s times 1, and B squared, so 1 squared, which would be just 1. And this would be your final answer, which is answer choice A. One thing I want to mention is sometimes when you factoring, you sometimes don't know if you completely done, but if you're doing the difference of cubes, this would not be factored any further. That would be it. Because sometimes you can factor something and then find a trinomial that you can factor furthermore, but not when it comes to the difference or sum of cubes. Okay, and while we at it, I'm going to go ahead and put the formula for the difference of cubes. So it's going to be a minus b, a squared plus ab plus b squared. So basically is if the number starts with a plus, the first one going to be a plus. If it starts with a minus, the first sign is going to be a minus. The only thing that changes, the first sign is the opposite of this one, and the next sign is the opposite, but the last sign stays the same. So if you have a hard time memorizing it, just go by this rule. First one, same sign. If it's difference, it's difference. The only sign that changes, the first sign, it changes to the opposite, and the last sign stays the same. Hope that helps. We're going to go to question. You can have either or on the final. We went through an example with a sum of cubes, but you could easily find a difference of cube on your exam, so be prepared for both. I have confidence that you can do either. Okay, so question number, which question am I doing? Number 8. All right, use the square root property to solve the equation. Okay, it specifically says use the square root property, so I know I'm going to have to find, no, I don't need to do that, not for this case. I was going to do something else, never mind. So first thing I'm going to do is subtract 2 from both sides. Then I'll have 6x squared. This cancels, and I'll have 1176 on this side. I want to leave the x by itself. I'm dividing by 6. I'm going to do this line really long so it gives the, what, Jedi Master? Yoda time to give me the answer because I don't, well, it didn't really work. I'm still waiting for the answer. Okay, thank you. So 196. And can somebody please tell me what cancels something squared? How can I get rid of the squared and just have a plain x? Because I'm not solving for x squared. I'm solving for x. Mm. How about Minions Jedis? Do you guys like that better? I just came up with that. That is so awesome. Minions Jedis. Yes, it's a modern world. Do I get an answer? Do you? My question is, how am I going to get rid of this 2 here so I can have just x by itself? What cancels something square? What reverse? Square root. Excellent. Whoever said that. Yes, I'm going to square root it. Now, if I square root it, if whatever I do to one side, I have to do the same thing to the other side. But when I do it to the other side, this becomes plus or minus. This cancels out, so I'm left with x equals to plus or minus 14. Yes? Okay, so yes, 14. And that's answer A on your review sheet if you print it out. Okay, so far so good. If you guys don't have any questions, I'm gonna move on. And okay, I guess I'm gonna move on. Question number 9. What? Okay, do you guys know who is this guy attacking us right now? Look at your screen. Look at your screen and let me know who that is. Somebody said it's a stormtrooper. Ah, I knew we have a Star Wars fans down there. I knew it. Had to have at least one. I didn't even know that. Okay, that's a stormtrooper. We're gonna get like blazed today. Anyways, let's move on to question 9. Solve the equation by completing the square. Oh, there we go, completing the square. That's what I was thinking I was gonna do on the next one. That's why I gave that big pause. Okay, I need to complete the square. Everything looks fine. If there was a number here, I had to get rid of it first, but that's not the case. So I'm just going to go ahead and work over here. So to complete the square, you get the, let's say, second term. What you do is you divide it by 2 and you square it. Whatever that number is right here, you cut it in half and then you square it. So in our case, it's going to be 1. So what happens is we'll have now w squared plus 2w plus 1. You can either add it and subtract it here, or you could add it to both sides. I'm going to do adding it to both sides because it's the same thing. And what I mean by that, I could have just done this. W squared plus 2w plus 1 minus 1 equals to 3. Because if you notice, if I add 1 and minus 1, I'm literally not changing this at all. But math can become very, I don't know, logical. So what I did, I just, and what my next step would be anyways, add it to both sides. So I cut that step. I went ahead and just added to here and added to the other side, which is the same thing. Now, by doing that, by cutting this in half and squaring it, I made this a perfect square trinomial, which means my answer should be in this form. So I'm going to square root this. That'll be w. Square root this, and that'll be 1. And I bring this sign, the first sign down here. So voila, that's your perfect square. and add the other side. So that's 4. We went over this already. What cancels something squared is if you square root it. So I square root it, and then I have to do the same thing on the other side, which means this becomes plus or minus. So if this cancels that, I'm left with W plus 1 equals plus or minus 2. At this point, I could go ahead and separate it this way. So I have W plus 1 equals a positive 2, and W plus 1 equals negative 2. That's where the plus and negative come from. So it could be either answer. Then I'm solving for W, which means I'm going to subtract 1 from both sides on this side. This cancels. I'm left with 1. Subtract 1 on this side, so W equals to negative 3. So I have 2 answers, which in your packet is D. So 1 comma negative 3. This is not a point, so I'm not going to put a parenthesis on the outside. Everything is good? Do we have a question? No, no question? Okay. Question 10. Solve using the quadratic formula. Okay, in order for me to use the quadratic formula, it has to be in this form. ax squared plus bx plus c equals 0. In other words, I need to make sure that everything is on one side and 0 is on the other side. To do that, I'm going to have to move this guy here and this guy here. So I'm going to add 8x here, add it here. Let me do it step by step. So I have 4. I have enough space to do that. Plus 8x equals negative 1. I'm going to have to add 1, add 1. So I'll have 4x squared. Actually, since I'm going to do the quadratic formula, I might not have enough space. Plus 1 equals to 0. Okay, so now is in this form. I have a number with an x squared, a number with just the x, and then just an independent number. Okay, what I'm going to do now is just figure out my A. Can somebody tell me what's my A, my B, and my C? Jedi minions. Do I get an A, a B, and a C? Okay. 4, 8, and 0? 1. 1. So A, look, let me put it right here next to you, to this actual formula. So 4x squared plus 8x plus 1. So this is my C, this is my B, and this is my A. So 4, 8, 1. Okay? So now let's move on to doing the quadratic formula. So my quadratic formula is going to look like this. So I'll have, the formula is negative b plus or minus square root of b squared minus 4 AC, A times C, over 2 times A. Okay? So now all I got to do is plug in what I know. So negative b would be negative 8 plus or minus 8 squared minus 4 times A times C. This goes all the way through, over 2 times 4. Okay, let me see if let's go, can I go over here? Yeah, let me do it over here and then I keep, because where? Here? Indeed. Looks like a 14, you're right. Okay, there we go. Then I'll have negative 8 plus or minus square root of, 8 squared is 64. I want to do the signs first. So negative, positive, and positive. So it's just going to be negative. 4 times 4 times 1 is 16. over 8. Okay? Now I'm moving right here. Had some fun doing that circle. Okay, so negative 8 plus or minus 64 minus 16 is 48. Everything over 8. 48, if you can recall, is not a perfect square, so we're going to have to work it out in order to simplify this entire fraction. So 48, like I said, I'm sorry, let me move it away from there. My preferred method of simplifying radicals is to do the tree, the factoring tree. It's very effective and I really like it. So I'm going to do it right here on the side. So 48 is 6 times 8. That's 4 times 2. This is 2 times 2. And this is 3 times 2. So I get all my prime numbers. So every time I have a group of numbers that are the same and it's the same as the index, that comes out of the radical. So I got 1 right here. So a 2 is going to come out. I have another 1 right here. Another 2 is going to come out. And I had a 3 left. So this will be 4 square root of 3. Guess I didn't manage my space right. So then I'm going here now. So now I have negative 8 plus or minus. We said it was 4 square root of 3 over 8. Now, the way you simplify this furthermore is if you can find a number that goes to all these 3 numbers simultaneously, then you can simplify it. Like say I had a number that went on this one and on this one, but it didn't go on this one, I couldn't. It has to go to all 3 of them. So my number here is 4. 4 goes into all of them. Then I'll have negative 2 plus or minus. 4 goes into 4 one time, so I'm just gonna, I can put 1 square root of 3, but we all know that's just square root of 3, so I'm gonna omit it. And 8 divided by 4 is 2. And this is your most simplified answer. Well, at least for the this class and for the choices that you have, because obviously you could have did it in the that could have done it in the calculator, figure out what square root of 3 and have your answer as a decimal. But up here is fine, which is number, not number, let's say number A, letter A on your script. Okay. All right. So Yoda, you up, right?
Okay. Before we continue, I have something else wise to say. Always remember your focus determines your reality. Okay, the next droid we are fighting is 11. So we have to find the quotient, which means basically divide these two thingies, or however you want to call them. Doing that, this looks like a lot of factoring because as of right now, we cannot really tell if there's anything that we can do. And also, when I see a division sign between them, I usually use the rule of keeping the first one, changing the sign to a multiplication, and then flipping the second one. So let me just rewrite it first before we start doing our factoring process. I'm going to keep the first one, so nothing changes on that one. And then I'm going to change the sign to multiplication. And I am flipping the second fraction. So now x squared minus 4x minus 32 is on top and 7x plus 7 is in the bottom. So starting factoring. This first part, 2 terms and a minus sign, tells me this is the difference of 2 perfect squares. So knowing that, I can easily factor it because that would be an x and an x, and I hope by now you guys have your factoring methods down. Then I know I'm going to have two different signs, and it doesn't matter which one comes first, and the square root of 1 is 1, so there goes a 1 and a 1. Okay, done factoring the top, going to the bottom. This is a trinomial, and I don't know if you guys noticed that, but it is a perfect square trinomial because this first term is a perfect square, this term is a perfect square, and the 8x I would get from multiplying 2 times the square root of x squared times the square root of 16 together, which will give me 8x. So knowing that, but you could also use the method of just factoring trinomials, should give you the same answer. But because I know this, I know I got an x and an x. This sign is positive in front of the middle term, so I know I have two positive signs, and then the square root of 16 is a 4. Okay, done factoring the second one. Now moving on to the third one. This also is a trinomial with a coefficient of 1, so I can regularly factor it by writing my two sets of parentheses, square rooting this first term, which gives me an x and an x, bringing down my first sign, which is a minus, multiplying the two signs together to give me the second sign, so negative times negative is a positive, and then finding the factors of the last number, which is 32. When I have different signs into these in these two parentheses, then the factors must subtract to give me the middle term, which is 4. And I'm using this rule so I don't have to worry about my signs, but there's many other factoring methods out there. If you have one that fits your style, stick with it. If not, then this one might be a good one for you to use. So the factors of 32 that subtract to give me 4. Jedis, let's fight this together. I'm waiting for some responses. Okay, but because I already did my signs, I don't really need the sign. 8 and 4 is correct. I'm writing my larger factor of these two first, and my signs match. But obviously, if you're giving me the answer with the signs, then you are using a different method, which is fine. The factors are correct, and I'm done factoring this trinomial. Now, my last one, these are only two terms, but this time I don't have the difference and I don't have the sum of cubes. So I'm going back to the basics, which is just pulling out the GCF. Both of them have a common factor of 7. And I'm left with x plus 1. Okay, I factored every single piece, so now I'm ready to cross out tops and bottoms that are exactly the same. So I got an x plus 1 here, and I cancel it with the x plus 1 in the bottom. And I also have an x plus 4 and an x plus 4. And then I think I'm stuck. There's nothing else I can cancel. So I'm going to just rewrite it nice. And I think you don't necessarily have to foil it back together. I think this is in your answer choices just like that, so you don't need to go the extra mile. But if you wouldn't find your answer, you should try foiling the numerator. And then in the bottom, I'm going to write my 7 first, and then x plus 4. So it looks nice. And in my packet, and in your packet as well, is somebody saying that? Okay. We have a sad message from the Jedis. We just lost connection. So I am going to talk really slow to see if we can get them back and they could see the screen. But I'm going to look in my packet to find the correct answer choice. Please Okay, we have an update. Our Jedis are back, so we did not lose them. They're actually fighting hard out there. So for this droid, the correct answer is C. Okay, if there are no other questions, let's move on to droid number 12. This one wants us to subtract the rational expression and then simplify our answer to lowest terms. Okay, remember in a previous problem I said when you have fractions and you can call them fractions, they are fractions, and it's subtraction, you need the same common denominator. In our case, we do not have the same common denominator. And remember, these pieces belong together. You cannot see them individually. So first step would be to find the least common denominator. This is probably also the hardest step. So I want to see how you guys doing. Please type in the least common denominator into the Cruiser text box right now, and then we go from there, and I will give you a hint or help if it didn't quite work out. So the least common denominator is something at the end that we should have uh, for both of them together as the final result in the denominator. So we got an answer from one of our Jedis out there, which is a Y. A Y is in the least common denominator, but it's not just a Y. Least common denominator. Another Jedi also responded, and that Jedi said Y minus 4 and Y minus 9, and that is correct. Remember how I told you these are pieces. So to make them the least common denominator, meaning something that both of these pieces go into, we actually need both of them because they have nothing in common. So Y minus 4, Y minus 9 is the least common denominator. Now this side already has Y minus 4 of the least common denominator, so the only thing we have to do is multiply top and bottom by the missing piece, which is Y minus 9. And then on the right side of our rational expression, we already have the Y minus 9 from our least common denominator, so we are missing the Y minus 4, so we multiply top and bottom by Y minus 4. Okay, now this is going to be a lot of foiling. So I'm going to start right here, foiling the top. First times first gives me a y squared. First times second gives me a 1y or just y. Second times first gives me a negative 9y. And second times last gives me a negative 9. Now the bottom. Again, first times first, y squared. Oh, yes. Yeah, okay. Thank you, Obi, Vanina, Kenobi. I'm doing too much work here. So actually, um, I don't need to follow the bottom one because if you look at the answer choices, it's going to be in not foiled form. So I don't need to do that much work. I don't need to foil the bottom. I can just leave it in this form. So y minus 9 and y minus 4, which we chose to be our least common denominator in the first place. So because we're only dealing with the numerators, we don't really need to follow the denominator. So right over here, you still have that minus sign that is very important. And now let's FOIL the second half. Remember, this is our least common denominator, the same like this. This was our goal, and we only needed once because we're combining these two problems. So we are focusing on foiling this top part. Y times y times negative 4, and 1 times y and 1 times -4. So let me see if I can delete this. So taking too much space here. Looking at my problem, the next step, so this is my least common denominator. The next step would be combining like terms in the numerator, which we have right here. So I am getting y squared 1y, it's actually not positive, 1y minus 9 would give me a negative 8y, and then minus 9. And over here, y squared -4 plus 1y gives me a negative 3y and minus 4. As you noticed, I still didn't drop my parentheses because this is the most important part, and I'm pretty sure you will get this version on the final exam that has this negative in there, because if that was positive, nothing would change and you don't have to worry about any parentheses. But because it is a negative sign, it requires you to keep the parentheses all the way until the end, because the signs of the second problem are going to change. You will have to distribute this negative sign to everything that is in this parentheses. So nothing happens to the first part. We can just drop it down. And now distributing that negative sign, negative times a y squared now gives me a negative y squared. And negative times a negative 3 gives me a positive 3y. And negative times -4 is a positive 4. My denominator still stays the same. Okay, we're still not done. We can continue simplifying to lowest terms. So right here, these are like terms, and a y squared minus a y squared actually cancel out. They are 0. And then moving on, these are like terms. So I'm combining these two. A negative 8y plus 3y gives me negative 5y. And then also these two are like terms. So negative 9 plus 4 gives me negative 5. And again, my least common denominator still stays. So we're almost there. Usually you check if something cancels out, and you can only do that if everything is in factored form. So the least common denominator is already in factored form because I did not FOIL it. But the top, I can use pulling out the GCF. Both of these have a common factor of -5. So I could factor it using the GCF, and I'm left with y plus 1 over negative y minus 9 y minus 4. So now you should be able to identify this solution in your answer choices. And even though these twos are switched, that is okay, because this indicates multiplication, and multiplication is commutative. So these could be switched. And in your packet, this is answer choice B. So I'm going to wait and give you guys a second to digest this and see if you have any questions or confusions that you want me to go over before we move into our next battle. Can help you with that. Okay. Somebody is attacking us. Can anybody tell us who is attacking us? I know somebody is out there that knows this guy, who has faced him before. Let me give you guys a hint. I think he starts with general. Yes, we got somebody. We still have our number one Star Wars fan right here. So this is General uh, I hope I pronounce this right. Grievous. Grievous. Okay, let's move on. Let's leave him alone. He can fight his own battle. We are going to fight uh, number 13. So simplify the complex fraction and write your answer in lowest term. This also is a division right here. And there are two methods of solving this. One I have showed previously where you keep the first one, change this division to multiplication, and then flip the second. But in this case, I want to use a different method because this is going to be much easier. What we are going to do is we're going to cancel the fractions. So first step, the hardest part again, find the least common denominator. So the denominators are right here. X, this one, you can make a denominator, which would be 1, and this one, and then again, you can make this a fraction, which would be 1. Can you tell me the least common denominator of all individual fractions? I guess this is a harder question than the previous one. There are no wrong answers. Only if you're attempting, you know if you are on the right track. Remember, the least common denominator is something that all of them would go into, or in other words, the least common denominator you could divide by each one of them. So it definitely has an x. Do we agree on that? Okay, because x goes into x. 1 goes into here because remember there's an imaginary 1 in front. So I would be able to divide 1x by 1, correct? Now x squared is not an x because this is only 1x and x squared represents 2x. So I'm going to have to update my least common denominator to x squared. Now I can check, is the x still in x squared? Yes, it is because x squared represents 2x's, which is x times x, x squared. So yes, this 1x from up here is in the x squared. And we already determined that the 1 is in there. So my least common denominator would be 1x squared or just x squared. So I'm going to multiply each individual term by my least common denominator, which means here is a term. So I'm going to multiply this by x squared. This is a term, so I'm going to multiply it by x squared. This is a term, so multiply it by x squared, and also here by x squared. So now, before you actually multiply them together, you can cross cancel. We already said that x squared and x share a common factor of x, so I could cross cancel this. X goes into x one time, and x if I take out an x from x squared, I am left with just 1x. Over here, I can cross cancel nothing, but over here, x squared and x squared in the bottom cancel out. And again here, nothing cross cancels. So now I'm ready to multiply my leftovers together, and I'm left with an x times 5, which gives me 5x plus, and then 3 times x squared. As you can tell, there's not going to be any denominators because this changed to 1, to a 1, and I don't really need the 1 in the denominator. Now the bottom one This canceled out, so I'm left with 25. And over here, 9 times x squared gives me negative 9x squared. As you can tell, using this method, I already made this starting fraction look much simpler. Sorry, did somebody ask that? Okay. Vanina doesn't like the red, so I'm changing back. Yeah, Obi Vanina Kenobi, sorry. Okay, looking at this problem now, I would attempt to factor it now because it looks like two factoring problems to me. So looking for the greatest common factor first, because I cannot identify any other factoring method here. They both have the numerator, both of them have an x in common, so I'm going to pull out an x. And I am left with 5 plus 3x. And then my denominator, oh yeah, now I see it. They are the difference of two squares. I have a minus sign. This is a perfect square because 5 times 5. And this is a perfect square because I could split this into 3x times 3x. So yes, thank you, Obi Vanina Kenobi. I just had a brain beep. I don't know if, I'm allowed to use that word on broadcasting, national broadcasting. Okay, so using the difference of two squares, I can write my two empty sets of parentheses. Then I know it has to be a 5 and a 5. I know I'm going to need two different signs, minus and plus, and the square root of 9x squared, which we determined to be 3x and 3x. Okay, so now I see that I have 5 plus 3x on top and in the bottom in common, so they cancel out. And I am left with x on top and 5 minus 3x in the bottom. So that should be my answer. And in your review packet, this is answer choice D. Okay, if there are no questions, we have to speed it up a little bit. Rationalize the denominator and simplify. Assume that all variables represent positive real numbers. Okay, rationalizing the denominator already gives you guys a hint. Here's my denominator, and rationalizing means that I cannot have a radical in the denominator. The tool that we are using to do this is multiplying by the conjugate. So the conjugate is nothing else than the same thing as the denominator, but with an opposite sign. So instead of the plus in the middle, it's a minus. But what we do to the denominator, we also have to do the same thing to the numerator to keep the balance of the fraction. So the top one would just be distributing the negative 6 to both of these terms, negative 6 square root of x, and in the bottom, knowing my goal and why am I using it, instead of foiling completely, because when you foil, the two middle terms would cancel out, I could just do first times first and second times second. I'm going to do the whole thing here on the side for you guys to see what I'm talking about. But if you recognize this as multiplying by the conjugate, you can use the short version of it because you know that the two middle terms are canceling out. So square root of x times square root of x gives me this. Then x times a negative 7 gives me a negative 7 square root of x, positive 7 square root of x, and then positive 7 times negative 7 is the negative 49. So here, this is what I was talking about. This middle term, when you use this method, should always cancel out. And knowing this, I could just multiply the first, multiply the two last, and that is it to save some time. But I'm not done because the square root of x squared, this cancels out, is just x minus 49. And it could be that the radical term is written secondly. Mathematically, that looks prettier for you to be able to identify it in the multiple choice answers, but it's still the same answer because I'm keeping the same signs. I just switched the terms around. So now you should be able to find this answer in one of the multiple choices, and this is answer B. Okay. Remember, rationalizing the denominator, multiply by the conjugate. If there are no questions, we're moving on to droid number 15. Okay, solve and check your solution. Again, this is also a radical problem, but in this case, we're using a different method. We are squaring it to get to eliminate the radical, but before we can do that, we need the radical all by itself. We still have this term there, so first step would be to move it to the other side, subtracting 5 from both sides. Now we are left on the left with x plus 7, and on the right we have x minus 5. Okay, so now we can use the method of squaring both sides to eliminate the radical because the square and the radical cancel each other out. So we are left with x plus 7. And over here, you cannot use this shortcut I showed you in the previous problem because this is an actual foiling problem and nothing would cancel out because remember, it's the same sign. I'm multiplying the same sign twice. The canceling out of the middle term only happens if you have opposite signs. So now foiling these, I'm getting x squared minus 5x, another minus 5x, and a positive 25. Oops, I wrote my 5 first. These two are like terms. I can combine them. So I get negative 10x plus 25. And then I am going to bring everything to one side. Because of this x squared term, it looks like factoring to me to find a solution. And for me to be able to factor, I need everything on one side for it to be equal to 0. So subtracting x from both sides, or 1x, to set it equal to 0. Okay, Obi, Vanina Kanobi got confused. And negative 10x minus 1x gives me negative 11x plus 25. Now, remember, I'm trying to set this equal to 0, so I have to subtract by 7. Subtract by 7. Obi Vanina Kanobi is trying to make it up to me, so she already calculated the answer for 25 minus 7, which is 18. So now I set up my factoring problem, and before I use any of the other factoring methods, I am just trying to plain factor it to see if we can do it. So it has a coefficient of 1. Let me just write it over here. which means I can straight write my empty sets of parentheses, x and an x, bring down my sign, which is a negative, multiply the two signs to give me the second sign, and trying to find the factors of 18, I got different signs, so they must add to give me the middle term, which is 11. Are there any factors of 18 that add to give me 11? 3, 2, 1, perfect timing. -9 and -2. So the factors are 9 and 2. In my version of factoring, the larger one always goes first and the smaller number second, and that's it. No worries about the sign. Because I have it set equal to 0, I take each individual part, set it equal to 0, and solve for x. -2 equals 0. So adding 9, x equals 9. And over here, I'm going to add 2 to both sides. And that gives me just x equals just 2. Now, with these radical problems, there is a little hiccup, and sometimes you have extraneous answers, which means that they do not work out. So when you're solving these kind of problems, you will always have to check. So let's check real quick if our answers are correct, or if there are some extraneous answers that are not part of the solution, by plugging them into the original problem. Let's plug in x equals 9 to our original problem. So we have the square root of 9 plus 7 plus 5 should be equal to 9. 9 plus 7 is 16. Square root of 16 plus 5 equals 9. Square root of 16 is 4. 4 plus 5 equals 9. And then 4 plus 5 is 9. And 9 is equal to 9. So this solution actually works out. Now, the second solution, let me make some room. What? No, I'm just fighting with the board. Okay. I think this should be enough. And that gave you guys a little time to start working ahead of me already. So if you did it, you should have noticed that plugging in a 2 in this case, 2 plus 7 plus 5, that this one does not work out. 2 plus 7 is 9. Square root of 9 plus 5 equals 2. Square root of 9 is 3 plus 5 equals 2. And 3 plus 5 is 8. And 8 is not equal to 2. So 2 is not a solution. It is an extraneous answer. So in your answer, in your multiple choice solution, be careful, because both of these are one possible solution, but just the 9 is also another possible solution, and the correct one for this one is actually B, which only has the 9 as a solution. So be really careful on this problem to pick the correct answer. Check your solutions and make sure that both of these work out. All right. Now let me say something nice. I don't believe it. That's what Luke said, who's not here right now. But this is what I say. That is why you fail, which means you need to believe to be able to pass. And this is a hint to switch over to Obi-Wan Kenobi.
Okay, I would like to request my name to be changed to Vanina Skywalker. From now on, you can address me as Vanina Skywalker. Only if you believe in yourself. Now, we are going to question 16. Okay. Okay, Amy can clean the house in 7 hours. That's good. When she works together with Tom, the job takes 4 hours. How long would it take Tom working by itself to clean the house? All right, so we're gonna do some use fractions to do this one and then get rid of the fractions to solve it completely. So what are we gonna do is, oops, why am I all the way up there? So fractions over by the person, right? Plus, again, the fraction. Well, let me call the first one person 1. And fraction over person 2. It's going to be equal to one entire job completed by both of them. Okay? So the first one is going to be 4 over 7 plus 4 over t equals to 1. I can't explain it because I don't understand.
Okay, 4 is the number that both of them was doing the job together, so the fractional part of the first person doing it by himself would be 4 over 7. Amy did it in 7 hours. And then the second fraction of the second person, which in our case is Tom, was 4, which was the time they would be able to both do it together, over t. We don't know, and this is the variable that we are actually looking for at the end, the time that Tom did it by himself. It's all equal to this one complete job.
Thank you, Yoda Master, for helping me out. I would not have done it this way, but moving on. Now let's solve for t. I'm going to choose the method in which whenever you have more than one fraction, I find the least common denominator and multiply just the numerator by that least common denominator. Can somebody tell me what is the least common denominator? It's blinking. 70. That is correct. So I'm going to multiply each term by 70. So times 70 times 70 times 70 all the way across. So here, if it makes you feel better, you could put it over 1. You could put this over 1 here. I don't have a fraction, so I wouldn't do that. So the 7's cross each other out. I'm going to ignore the 1 because it's not really needed because any number over 1 is the number itself. So t times 4 or 4 times t will be 4t. Here, only the t's cross each other out, ignoring the 1. 4 times 7 is 28. 1 times 70 is just 70. Okay, solving for t. It doesn't matter which way I bring them. I'm just going to do the one that I would have to do the least amount of work, which would be subtracting the 4t from both sides. This would cancel. So 28 would equal to 3t's, right? Divide by 3, divide by 3. So canceling out, t equals to 28 over 3, which I can make it into a mixed number because I don't think 28 over 3 in terms of time makes a lot of sense. So 3 goes into 28 9 times. The denominator stays the same, and 9 times 3 is 27. So 9 hours in, I don't know, and 33 seconds. Because 3 goes, 1/3 is 0.3333. So let's just say 9 hours and 33 seconds. Any questions? Okay, so, and that's on your script. Call it script, but it's going to be A. Okay, number 17. Let's go. All right, brace yourself. This is one of the hardest questions ever. We're going to determine. I'm just kidding. It's actually the easiest question. This is actually a freebie on your exam. If you get one of these and you don't get it right, I'm going to be pretty, I don't know. Mm, Somebody's talking, upset. All right, so it's saying determine whether the graph is the graph of a function using the vertical line test. And interestingly, they already telling you what should you do to find whether it's a function or not. If they didn't tell you, this is the best way to find, if you only given the graph, the best way to do it is just using the vertical line test. Basically, it only means you would check if you do a vertical line anywhere on the graph. If it crosses more than 1 point, then it's not a function. And as you can see, I could have stopped at 1 because only one line would have been enough, and I would have seen that this is not a function because basically almost all of them crosses more than 1 point. So this is a no. Now say, I'm just going to give you example. Say you have a graph right here. You do the vertical line test. If I do any vertical lines throughout this entire graph, it's only going to cross at 1 point. So that this one would actually be considered a function. Okay, moving to next one. All right, can somebody name this weirdo? No disrespect to the Star Wars fan. He does look weird. I mean, it looks like an ant and like and steroids with combined with a machine. Doesn't matter. Okay, so what is it? Did somebody answer? Okay, so, all right. I guess I'm being rushed over here. So I'm going to go to question number 2. All right. They asking me to find f of -9. Okay, so you see this f of x right here. Normally it's just an x, but this time they told me that x is actually -9. So all I need to do is go on the function and plug in x for -9. So I'll have 6 times -9 minus 14. So -9 plus 4 is -5. This will be -63, right? Minus 14. So I'll have -5, 7, and 7. Oh, I'm sorry. Nobody told me. I'm sorry, guys. I guess 9 times, I guess, I'm not sure, but somebody's saying that 9 times 6 is 64. What do you know? Okay, so that's 54. Oh, which means this one is not right either. This? No, that's fine. So then, okay, real quick. -68. 5 and 8 don't have anything in common, but however, negative and negative cancel each other out is going to give me a positive. So my answer should be 5 over 68, which is C. Okay? She missed it. Okay, so we finding domain for question 19. The domain for a polynomial is always all real numbers. So there's no more, really, there's no doing in here. You just need to know that if you have a polynomial, you shouldn't be having any restrictions. And by restrictions, I mean, like, for example, when you have a fraction. For example, the question before, if you asked to find the domain, you would have a restriction because you know any number over 0 would be undefined, and then you would have a problem for the question before. But this one, you just need to know that a domain for a polynomial is all real numbers. for a graph, let me see. It would look something like this. Okay. So you know your domain because this is a 5. So let's say 1, 2, 3, 4, 5. 5 is right here. Went up 5. So this would be the parabola. Maybe not that wide. Maybe a little bit less. Yeah, something like this. Okay. So you know domain is from your on your x values from left to right. So looking at left to right, you would have from negative infinity to positive infinity, i.e. all real numbers. Okay, pen. Okay, next question. Yep. All right, number 20. All right, there we go. We're finding the domain of a rational function. And this is what I was referring to. So we have it. I don't need to copy that. Never mind. Okay, whenever you're finding the domain of a fraction, or otherwise known as a rational function, the only thing you need to worry about is the bottom part because as you know, any number or anything over 0 is undefined, meaning you cannot if there was any x that would make this bottom equal to 0, then it would be undefined and we don't want that. So what do we do is to find what makes this equal to 0, we set it equal to 0. That is to find out what makes it equal to 0. So we make sure we exclude that number from the domain. And the best approach here would be to factor this one out. Oops. So I have x in x. My signs are plus and plus. Bring first one down, multiply the two signs. Factors of 54, that gives me 15. I'm just going to cut it short, is 9 and 6, right? Equal to 0. So I'll do each one equal to 0. Set each one equals to 0. Add subtract 9, so x equals to negative 9 and x equals to negative 6. Basically, what this means is if I plug in x here for negative 9, it's going to make this entire thing a 0 if I plug it in. Or if I plug in x for negative 6, this entire bottom is going to be 0, and I don't want that. That's why my domain should be any number in the world, but not these two guys right here, because these two guys would make this function undefined. So it didn't specify whether you should answer the question in interval notation or any other way, and it looks like they did it in set builder notation. So your question, your answer is C, which is saying that x, such as x is a real number, and x has to be different than negative 9 and negative 6. Okay. Oh, I guess it's Yoda's turn. Okay.
Okay, Yoda is back. It is not your mistakes that need to define who you are, nor what you become, but whether you learn from them will. Let's fight droid number 21 now. Graph the function by plotting points. Okay, so in your case, you have multiple choice answers, and there are most likely 3 of the points are given. So right down here on the slide, I put possible values for x based on the multiple choices that you have in your packet and possible values for y. What I am going to do is I'm going to pick some of them and we'll plug them into the function. So let's start with -4. -4 is my x value, and plugging this into the function, I would get 1 over -4 minus 3. This gives me -7 in the bottom, And if I convert that into a decimal, 1 divided by -7, rounded, 0.14 in a decimal. So -0.14 in a decimal. It's easier with decimals when you're graphing because I have no idea where is -1/7 on the coordinate system. Okay, let's choose another point. Let's choose -3.25 as our x value, and plugging this into the function, we are getting 1 over -3.25 minus 3, 1 over -6.25. And if I divide that with my calculator to put it into a decimal only, I get -0.16, -0.16. Okay, trying -2. Plugging -2 into my function, I am getting 1 over -2 minus 3, which gives me 1 over -5, and converting that into decimal, I get -0.2, -0.2. And choosing +2 as my x value, plugging it into the function, 2 minus 3 is 1 over -1, which is just -1. Okay. I'm running out of space, so I'm trying to choose a number that I like. I'm going to pick a y value this time, because you also can do that with the y values, but obviously you're going to have to actually plug it in for y, which might be a little bit harder to solve it, because now my y value is f of x, so 1 equals 1 over x minus 3, where I would have to multiply both sides by x minus 3 to get the x to the numerator. So I have on this side, it cancels out, and I would have x minus 3 is equal to 1, adding 3, adding 3. So that gives me x equals to 4. Okay, I'm going to look in my packet now and see if I can, by any chance, find anything. I can also try to start graphing it on my coordinate system. So for example, the first point would be -4 on the x-axis, 1, 2, 3, 4, and then -0.14, which is possibly right around here. And then I have -3.25, so 1, 2, 3, 25 is maybe here, and then -0.16, oh, I'm making too many dots here, right here, and then I have -2 and -0.2, so it gets really close. Yeah. And then 2 and -1, so 1, 2 on the x-axis right there, and then 1, 2, 3, 4, and 1. So knowing that this is a fraction, um, you might needed to know that the actual graph of it is going to look like this, which is called a reciprocal function. So the original one would look like this, but ours obviously, because we have a -3 right here, would be shifted. So it would look something like this. Let me see, where's 3? 1, 2, 3. So here would be the axis, oh my gosh, the axis of symmetry. Let me try to do this a little bit better. This is the axis of symmetry. And if you see the bottom one, this is the axis of symmetry in the original one, which is at 0, but because the -3, it got shifted 3 units to the right. So now this should look like, oh, where's my pen? Right there. It should look like something like this. And then the top one should look like something like this, going through those points that I just marked. And if you look in your packet, this should be answer choice B. Yes, you can use the calculator, and you can also graph it by plugging that into the calculator. I can show you guys that real quick. And also the calculator has the option of giving you this without you having to manually calculate it. So let's go. Let's go real quick to the graphing calculator right there. So do you have the original equation? I just changed my, oh yeah, I got it here. So going to y equals should bring up this window, and then you're just typing in the function that you were giving. In our case, it was 1 divided. For division, we can use this. Open parentheses, that's very important. And x is right there, minus 3. And then you can hit graph to see if you can see this function on the graphing calculator right there. So you can check your multiple choice answers if you are able to find it already. If you are not sure and you want to make sure based on some specific points, you see how it says table in blue there. You have to press second first, then graph, which will bring up the table. And then you have choices to plug in for x. So in our case, some of the x options, for example, where I had an x value for 2, so 2, I also had an x value for 4, 3.25. Also, what did you say? I had a -2 and 0.25. So now I have all those values, my x and my corresponding y, for this particular function that we were given, and I can compare them to make sure that I actually pick the correct graph. Graphing by hand would be really hard, because especially for those kind of graphs, you would need a lot of points to be able to trace it. Okay, so let's go back to our slide. So we found the correct answer. It was B. Question number 22 asks us to graph the function by starting with the graph of the basic function and then using the techniques of shifting, compressing, stretching, and or reflecting. So, sorry, we just had a little interruption. So we are going to use this methods of shifting, compressing, stretching, and reflecting to move this graph of the basic function. And this is actually a cubic function, because right here we have a cube. I need my pen. This is a cubic function, so this is how the basic cubic function looks. And then usually you could have something inside the parentheses which is combined with the x, and you also could have something out here. Let me put it in red. And let's say this is 4, because you never know what version you're going to get on the final exam. I want to make sure that you guys know both parts. Okay, so the part that is attached to the x within the parentheses tells you if it's going to be shifted right or left, and it is going to be the opposite. So if you have a +2, it is going to be shifted to the left, to the opposite direction. If you had a -2, it would be shifted 2 units to the right. And for the last part, this tells you if it gets shifted up or down. But in this case, you do not need to take the opposite. It's going in the actual direction of the sign. So if it says +4, it gets shifted 4 units up. But in our case, I made this last part up. So we only have this, knowing that this is the basic function, knowing that it got shifted 2 units to the left. So from here, 1, 2, here's another one. So 1, 2, you can pick any points on there and just shift each point 1 to about 2 units to the left direction. 1, 2, and then just trace this new cubic function, which should look something like this. So it should be looking exactly the same, except for that it was shifted 2 units to the left. Yeah, you can also do that on the calculator if you think that your graph is not, that precise. So you would just plug in under y equals x plus 2 in parentheses and then raise to the third power, and you should see this second function that I just graphed. And then you should see that this is actually answer choice C. Okay. If there are no questions, then we are going to move on. This is 23, and it says find the vertex of the graph of the quadratic function. Because it says graph, I'm going to use the graphing calculator. And let me just switch real quick. Right, there's my calculator. Go into y equals. I'm going to delete my previous function. This was question number 23. So I'm going to type in this quadratic function exactly how I see it. Whenever you have a first negative sign, you should use this one rather than this one. Otherwise, you're going to get an error message. And then 3x squared plus 6x and then plus 1. If you still wasn't able to buy a graphing calculator on the day of your final exam, you can get one either from the depot, the library, or in building 1, room 143. Going into either 143 or 142, it's like an inside room. All of these 3 locations let you borrow calculators for free. Okay, continuing with our problem. I finished typing in this function into the calculator. I'm going to make sure that I can see it on the graph, because this question is asking for the vertex, and the vertex on a parabola would be either the maximum or minimum point, the all the way up point or the all the way down point, depending on how the parabola looks. In this case, I would have a maximum. So I need to make sure that on my graph that I actually see this maximum point. Otherwise, I have to change my window. Okay, so I see my point. Now I'm going to hit second calc, and on the graph I saw it was a maximum, so I'm going to use number 4. If you see that your graph has a minimum as a vertex, then you need to choose number 3. But in my case, it was a maximum, so I'm going to choose number 3. Something is blinking. What? Did I? What did I choose? Did I choose number 4? Oh, sorry. Now I'm going to go back to double check because I don't remember anymore what I pressed. So I did have a maximum. I need to choose number 4. Okay, there we go. And you see something blinking and it says left bound. So I need to be on the left side of the maximum. In this case, I'm already on the left side, so I'm fine. I could hit enter. And then it asked me for the right bound. So obviously this is not the right bound of the maximum. I have to move over to go to the right side. It doesn't matter where, just make sure you pass this maximum point enough that the calculator actually lets you calculate the correct maximum. This is okay. Now it asks me to guess. I have to hit enter again. So you end up hitting enter 3 times. And now it tells me the maximum is going to be 0.99. So you can round that to 1, and the y value of this maximum is 4. So 1, 4. Let me go back, to our slide. And we said that the x value of this vertex was 1. And remember, this is a point. Why am I putting negative? It was positive. Positive. Positive 1, right? Comma 4. Remember, graph looked like this, and the vertex would be this upper maximum point, and that is at 1, 4. In your packet, that's answer choice A. Okay, here we got somebody else attacking us, but we don't have no time for this right now. So we're moving on to question number 24. And this one says that the owner of a video store has determined that the cost C in dollars of operating the store is approximately given by C of x equals 2x squared minus 32x plus 680, where x is the number of videos rented daily. Find the lowest cost to the nearest dollar. So if you are giving a function and it has a square term, then most likely it is a parabola. Lowest indicates that it possibly has a minimum right there. This is what we need to find. So either we could choose graphing again, or we're using the vertex formula, which is to find the x value of the vertex is negative b over 2a. And remember, Obi Vanina Kanobi already wrote it down for you previously that this is a x squared. This would be b x, and this will be representing the c value. So either method is okay. I wished I had more time so I could show you both. So I'm relying on you guys to text in your Cruiser textbooks real quick which method you want me to do. Use the formula or graph it. Because both of them are going to give you the same answers, and I don't have no time to show both of them. So I'm going to relying on you guys to decide which method you guys want me. The formula, okay. Somebody decided. We're using the formula, so we're plugging in the values. Negative, and our b is right here, which is also a negative, so it's going to be negative 32 over 2, and our a value is 2 times 2. Simplifying this gives me a positive 32, and 2 times 2 is 4, and 32 divided by 4 should be 8. Okay, so we found the x value of this minimum point, but the x value represents the number of videos. The question is the cost. So we have to go back and plug this x value into our original function to find the actual cost at this minimum value. So let's plug in 8 for x into the original function to find our corresponding Y value, or in this case, the C, which is the cost, plus 680. Okay, so 8 times 8 is 64. 32 times 8 is 256. And then 2 times 64, 128. And then in the calculator, all together is 550. What? 552. Okay, so this would be my cost to the nearest dollar amount. And then your answer choice, next page, is B. So you can do it like in the previous problem by plugging it into the calculator and finding this minimum point, this minimum Y value, or you can use this very important vertex formula for the X value of the vertex to calculate it mathematically. The next question is find the power of I. Okay, you only need to know for this particular problem, you only need to know two things. What is I and what is I squared? I, you cannot simplify it, it's just I. So you don't really have to remember nothing for that. But I squared is -1. So this is the most important one, I squared. And then you can solve any of these problems that have a different, and probably you will get a different version of it on the final exam, that have a different number on top. So you see this little 2, you need to change the 9 that you have multiples of 2. So what I mean by this is that we are going to split up this I to the 9th power first of all into even and then a leftover, because even numbers would be divisible by 2, correct? So I'm going to split this into I to the 8th power and a leftover I, because remember, when you're multiplying variables, you would add their exponents. So 8 plus 1 is 9. So this is still the same, I to the 9th power. I just split it up into even numbers, so it matches this too. Now I can rewrite this to make it I squared. And I'm going to raise it to a power. And remember, if you raise it to a power, they would be multiplied. And to give me 8 at the end, I would have to multiply it by 4. So I can rewrite this as this to make it I squared. But I still have my I to the 1 power, or just I right there. So now I know that I squared right here is -1. So I'm going to switch it out. -1 raised to the 4th power times I. And negative raised to an even exponent is always positive. So I know this -1, when I do this, multiply it by itself 4 times, becomes a +1, and I still have my I. So I know this I to the 9th power is just I. It's just I. It's me. Yoda. So all of them are not coming to be me or I, depending on this number, obviously. So you should practice a few different ones. You can take the review as many times as you want, and you should have different versions of this problem popping up for you to see if you can also split them and come up with the correct answer. So let me say something wise. Fear is the path to the dark side. Fear leads to anger. Anger leads to hate, and hate leads to suffering. So don't suffer. Stop hating math and just pass this final. So switching over to Obi Vanina Kenobi, we got 5 more questions to go.
Okay, this is to I'm not gonna, okay, I'm just gonna speed it up because we don't have much time and I want you guys to get all these questions. Write in terms of I. This is the same thing as writing in negative square root of 1 times 288. I haven't changed anything because if I can times them together, go back to this, right? So the negative square root of 1, um, if you are familiar with this, that's I. So I know I'm going to have I. Now I'm going to break this one down. Can you break it down for me? What's 288 divided by 2? 144. So 144, and this is, I guess I could just leave it as square root of 2 times square root of 144. 144 is a perfect square of 12, so I'll have 12 I square root of 2. Does that make sense? I kind of rewrote it differently so it looks conventional, but then, like, let's say I didn't, I would have I square root of 2, I can't do anything with it, times square root of 44, which is 12. Then I just rewrote it this way, 12, because this is multiplication. 3 times 2 times 3 is the same thing as 3 times 3 times 2, and so on and so forth. Okay, move on. All right, number 27. All right, we're going to multiply using FOIL. So first one times the first one is 9. First one times the second one is 24I. First one times the first one again, that's 12I. And first one times the second one would be positive 32I squared. Combine like terms. I get 9 plus 636I. I square is the same thing as negative 1. We talked about this on the previous answer, so I'll have plus 32. Change this to negative 1, meaning this will become a negative 32 plus 36I. Combine my last like term. What's 32 minus 9? Okay, so I'll have negative 23 plus 3I. Okay, I'm sorry. Oh, plus 36I, I'm sorry. Okay, which is question choice, answer choice B. Okay, and the one from before was question choice A. Right, number 20. Oh, okay, who can name this? All right, you can put it on the cruiser box. I'm gonna move on. Thank you. Question 28. Okay, the best way for me to solve this would be to multiply by its conjugate. We talked about conjugate before. Who? Kylo. Oh my God. I don't know these people. 5 minus 6i. Okay, is that what it is? Because that's not what you had. Mm. You didn't write that one? Okay, so basically I'm just multiplying both top and bottom by the conjugate. Conjugate just means that I keep the whatever I have, the terms, but I switch the sign to its opposite sign. Okay, then I'm gonna do some foiling up top. Let me put this in parentheses real quick. So I'll have 15 minus 6 times 3, 18i. First times first, negative 10i. Negative and negative positive. 6 times 2 is 12. I squared, right? Like we said before, these two would, all you need to do is square, multiply just the, the one by itself and this one by itself to get the answer. Because I don't know if you noticed, this comes from a difference of two perfect squares, so it should have makes sense that that's the answer. So this would be negative 36I squared. Okay, we're gonna combine like terms. So I have 18 and that will give me negative 28I. I'm gonna change this to negative 1. So 12 times negative 1 is negative 12. I'm going to add this 15 right here. For the bottom, I'm going to do the same thing. I'm going to change this to negative 1. This is negative 1, right? I'll have 25 minus times negative 1. It'll be positive. So I'll have positive 36 on the bottom. Still have some like terms to combine on top. Then I have negative 28I plus 3, everything over 61, is it? Over 61. And it seems that in your pamphlet they split it. So they have the same denominator, so I can just split it into this 61 plus 3 over 61, which is answer choice A. Okay. What? They want me to use the quadratic formula to solve this equation. Okay, let's do it. So real quick, my A is 1, my B is 14, my C is 85. So I'll have negative 14, pull out the calculator, Deanna, 14 squared minus 4 times 1 times 85. No. And 2 times 1. Do I need to write the formula? Let me write it just for reference. B squared minus 4AC over 2A. All right, so what's 14 times 14? 196. What is minus 340? Okay, thank you so much. Over 2. So what's that gives me? What's 196 minus 340? Negative 144. Beautiful. It came up to a perfect square, which is what I was hoping. Which we can do this like we did before. That's the same thing as negative 1 times 144. Negative 1 is the same thing as I. 144 is the perfect square of 12. So then we'll have, let me go here, negative 14 plus or minus 12I over 2. Like I said, if you can find a number that goes into all these three numbers down here, then you can simplify this. So 2 go into all of them. So then I'll have negative 7 plus or minus 6I, and that would be it because 2 goes into 2 once, and I don't need to put it over 1. And that's letter D for you. Okay. Simplify the expressions. Okay, let's go to this one real quick. Okay, this one, what you need to do is we actually going to distribute, right? But remember that when you doing multiplication of exponents, you have to actually add the exponents. So I have 2 times 4 is 8. X negative 1/2 plus 2 minus imaginary 1. So 2, negative 2 times 1. X negative 1/2 plus 1/2. Okay. This one cancels out, but it doesn't cancel out to a 0. It actually cancels out to a 1. So this one would just be negative 2x. I cannot add or subtract fractions that don't have the same denominator. My common, wait a second, negative 2 over 2. Okay. All right, I see. Hold on a second, guys. I'm giving you the wrong information here. No, yeah, I said it right, but I did something else. Okay. It cancels out to a 0. So it'll be x to the 0 power. And I'm sorry, x to the 0 power is equal to 1. So negative 2 times 1 would just be negative 2. Now on this side, I'll have to find the common denominator, which is 2. So times by 2 times by 2, negative 1 plus 4 over 2 will be 3 over 2. So then I'll have 8x raised to 3 over 2. I did fly through that one. So your answer choice is B. Whew. You're up, Obi-Wan Jedi. Forgot.
Okay, guys, this was a lot of questions, so you're also going to have unexpected on your final exam. The numbers probably just change, but the steps, everything should be, you know, the same and the same formulas. So if you practice the online review, then you should be good. In a dark place, we find ourselves, and a little more knowledge lights our way. So I hope this is how you feel now. Let's go over final exam information. The final exam is going to be on the Osceola Campus Testing Center like the previous tests before. The final exam actually opened today, and it will close exactly 1 week from today on the 16th at 7 p.m., which means 7 is the latest you can get into the testing center. The testing center closes at 9. This only gives you 2 hours to do your final exam. For the 30 questions, you have 2.5 hours to do the actual exam. So you should give yourself enough time before closing of the testing center, because you saw it. I mean, we were talking a lot. It is possible to do it in less than 2.5 hours, but if you want to double check yourself and don't feel under pressure, give yourself enough time, give yourself 2.5 hours to take your final exam. You will be allowed a graphing calculator, either the TI-83 or the TI-84, nothing above that. So no Inspire, no other fancy things. And like I said previously, you can get these calculators for free for checkout. You only need a BID at the Osceola campus at the depot, which is in building 4, room 121. Also in the library, which is upstairs, the same level of the testing center. And at building 1, which is on the other side of campus, in room 143, room 143. You are not allowed to bring any notes or notebooks for taking the final exam. You will be giving scratch paper from the testing center. You do not need to bring your own scratch paper. Very, very important, bring your VID, Valencia ID. You will not be able to take the test without this ID. You might need to know the CRN of this class, which is 14221. So it's easy for the testing center to find the record that I have already submitted for you guys. And this course is MAT1033C. When you are asked for your instructor, you can either use my name or Dr. Pedoni's name. In the bottom, I wrote down the hours of the testing center, and now I'm going to answer some of the questions that we have from our Jedi audience. For example, Somebody is asking if I guess she could be taking that test on Saturday. Yes, if you are planning on taking it this Saturday, you are. You are able to take it on Saturday as well. I guess it just didn't show up on the slide, but I know that the Osceola Campus Testing Center is open on Saturdays. I'm not sure from what time to what time, so make sure you check on their website or call them to find out exactly what time they're closing, so you could be there 2.5 hours before they close. So you are also able to take it on Saturdays. Somebody else had the same question. No, I guess it just didn't show up on the slide that Saturdays also was an available day for you to take it. Just make sure you do not try to take it after the due date, which is the 16th of December. Don't forget to complete your homework by Sunday night this week. Study as much as possible for your final exam. You can always email me questions or set up an appointment in person to prepare yourself. And after the due date of the final exam, I will go ahead and put in all your grades into Blackboard, which I believe I should be done by Thursday or Friday, but I will send out an email. And if you are eligible because your final exam score is higher than your lowest test grade, then I will replace the score of your final exam for your test grades to give you a little boost and maybe help you to get a better grade if you happen to mess up on one of your tests, or if you had an excuse for not showing up for one of the tests and received a 0. If there are no more questions right now, then I am going to log off. Thank you for attending the study session today. It's always more fun to do it with the audience rather than just basically talking to yourself. I wish all of you good luck on your final exam, and I will be checking on you and seeing if you need anything and how you did on your exam. You can email me if you have any further questions. Again, thank you so much, and I hope you have a good day. May the force be with you, and don't forget to watch the movie on Friday. Bye now. Oh, dang it. Seriously?